Okay, let's finish up with some word problems here for this unit, sinusoidal functions and periodic phenomena word problems. Let's look at this scenario here. We're talking about temperatures at Kawartha Lakes, modeled by this equation here, the temperature, big T, at little t, where t represents the number of months, so time, I guess, in months, minus is equal to minus 22 cos 30t plus 10, and then a bunch of questions. So let's think about this for a second here. We have normally a cos curve looks like this, but this guy here has been flipped on its head. It's a negative cos curve, so reflected cos curve. So that's going to look more like this. What's up is down and down is up. Okay, so that's our black curve there is the one we're looking at. And let's answer some questions and see if we can make sense of this sort of thing using our help of this. What is the period? Well, the period we've said before is 360 over, period is K, and 360 over K is your period. So let's figure out what's going on here. 360 over K, there's your A here, there's your K here, so 30. And the answer is 12. 360 divided by 30 is 12. And you might ask yourself, well, 12 in time, and I got months, so what's going on here? It's 12 months is my period. So how long does this temperature cycle take? It takes 12 months or a year, which makes sense, right? Temperatures kind of fluctuate and repeat themselves year by year. So that's that. Maximum temperature and minimum temperature. So what we'll look at here is, let's make sense of what's going on here. So I have, look at my C. My C says I'm at 10. So my curve looks something like this. It has a max and a min, like this, okay? And I look at it, and don't worry about the phase shift right here. We're just looking at the y value, or the, I guess in this case, the big T value, the temperature value. And I've shifted up from, our normal rest is 0, right? So you have your normal cos curve here, sorry, is at 0, but I've shifted it up 10 degrees. So this is at 10. And here I have an amplitude of minus 22, which means from top to bottom, sorry, an amplitude of 22. I have an A of minus 22, but remember when we talk about amplitude, we talk about the magnitude. So we just worry about the sizes. So from here up is 22 more, so I get up to 32. That's the amplitude, or that's my A. And then another 22 below, so I get down to 0, and then I keep going, I get to minus 12. So 10 minus 22 is going to get me to minus 12. Does that make sense here? These are 22 apart, these are 22 apart. And then let's see if we can make sense of this. What's the maximum temperature? Well, that's the top temperature, which is 32 by max. What's the minimum temperature? And that's minus 12, which is right here. Okay, they're 22 apart from here, from the rest temperature. What's the range? The range is just this. We're talking about range as far as y's go. So our range, instead of y, we have this. It's between negative 12 and 32. So just taking what we have up here and representing it the way we kind of represent range. You don't have to worry about representing it as a real number and that sort of thing. Let's keep going. Blood pressure question. Let's whip through this. What's the period? So here's this. What you would do here is take your 360 divided by 300, and you can answer the questions on this on your own. I just want to move on to one last question, which is going to be the Ferris wheel question. So as you can see, I've already messed around with this a little bit. Here's a Ferris wheel question. You get on a Ferris wheel. People get on a Ferris wheel at the bottom of the Ferris wheel, which makes a lot of sense. Probably the safest way to do it. And they also hopefully get off at the bottom of the Ferris wheel, which I guess is more important. The graph shows how a person's height above the ground changes during the first rotations of a rise. They go up, they go down, and they go up, and they go down. And unfortunately, it looks like they're getting thrown off at about 12 meters, which is not that great. But if you've ever been around the people that run the Ferris wheels at the Western Fair, that might make sense. So let's move on. Write an equation to express a person's height above the ground. So our height, our equation here is going to have our A's and our K's and our D's and our C's. And remember that what we usually have is we have sine here, K times theta. Okay, but in this case, instead of theta, we're going to use time, which is here time in seconds. So K, and we'll put a T there instead of theta and clean it up like that. So A sine K, bracket T minus D, bracket, close bracket plus C. And I'm using sine. You don't have to use sine. This actually looks, remember what sine looks like. A sine curve looks like this. A cos curve looks like this. Okay. So look at this one here. It looks like neither. It's starting at the bottom, not at the top or the middle. So you can choose what to do. I'm just going to ignore it. I'm going to put sine. Sometimes I'll ask you for sine or cos. We can do both after. But let's take a look at this here. Let's just go through it and find out what A is and K is and all these things and sub them in. Okay. So first A is my amplitude. You can look at this right here and tell me right now what my amplitude is. It's 20. Another thing you can do is to go max subtract min. So top height is 40, minimum height is 1, and divide by 2, and that's 20. Either way, your A is going to be 20. Okay, so that's that. Our next thing is our K, and K, if you remember, is 360 divided by your period. Gets me K. And in this case, let's figure out what the period is. Okay, from bottom to bottom is 40 seconds. Okay, so period is 40 seconds. Let's reconfirm that. From top to top is 40 seconds. Okay, and even from here to here, 10 to 50, I'm at 40 seconds. So that's that. That's 9. 360 divided by 40 is 9. So K is equal to 9. So that's that. A is 20. We said that's 9. D is going to depend what you're looking at. I said let's work with the sine curve. A sine curve starts, let's look at a sine curve. A sine curve starts, sine curve starts at rest, this green guy here. So let me reduce sine curve. Sine curve starts at rest and goes up. When am I at rest and going up? I'm going up right here. So that is then D is equal to 10. So I'm at rest here and going up here. So there's my sine curve. D is 10. If I use cos, I would change that. And let's hold off on that for a second. So that's 10. And then C is what's my new rest position, and it's 21. So rest position of 21. I take the whole curve. It was at this guy is based at 0. This guy here is shifted up 21. So I'm up 21 for my C. So let's sub that in now. So I have A, which is 20, sine K, which is 9, T minus 10. Okay, so right 10 minus 10 plus 21 because I'm up 21. So that's a 9, not an 8. Okay, so that's that. If it was a cos curve, if I asked you for a cos curve, that's not right, but a cos curve starts up top. So I could start here and change that to minus 20 if I was doing cos. The other thing I could do is this if I wanted to do cos. A cos curve that's been reflected starts at the bottom and goes up. So this is actually, if I didn't want to have a transformation at all, and I just wanted to have t, I could have said 20 minus 20 cos t plus 21. Okay, so this is an inverted cos curve starting at the bottom here, all the way up. You don't need to do that though. You can just start it here at the top at 20. Okay, so you can start at 20 for your cos curve, and that would just be this 20 cos 9 bracket t minus 20 plus 21. And again, don't forget, these should be a quarter of a period away from each other. The period is 40. They are 10 away from each other. So that's that. What else do we have here? What's the person's height after 15 seconds? What you're going to do is you're going to sub this in. I'm not going to do it right now, but you're going to sub t at, you're going to find this. So this is t at t, big T at little t. So t at 15 is equal to that. Sub that in. And then you're going to just throw this in your calculator, okay? And this is sine 9 times 5, so sine 45. So sine 45, throw it in your calculator and get your answers. Sine 45 is this, times 20 plus 21. Be careful with your calculator stuff. And also, when you check this out, look, there's 20, there's 10, where's 15 right in the middle? I'm looking at a height somewhere around 30-ish. Okay, so check that out. See what you get there. What's the radius of the Ferris wheel? What's up with that? What's that even mean? Well, think about a Ferris wheel. Okay, if I have a Ferris wheel, there it is. Okay, there's my Ferris wheel, named after some guy named Ferris, a French guy. Something to do with the Eiffel Tower and the World's Fair and all that stuff in Paris, I believe. Either that or I just made that whole story up. Just go with that. Okay, so here's my Ferris wheel, and remember what a radius is. A radius is half the diameter of this diameter. Here's a radius, so it's the distance from the middle of a circle to the end, or half the distance, half the diameter, half the distance across. So there's my radius, and if I said that my max height, look at this, my max height is 41, my minimum height is 1. So think about that for a second. I go up to 41, I go down to 1. So this then is the difference between it, 41 and 1. This would have a diameter of 40. Divide that by 2. My radius would be 20. Okay, it's also, yikes, equal to the amplitude. And if you think about that for a second, the distance between the rest position and the max is the amplitude. And if you have a Ferris wheel, okay, a Ferris wheel, it's the distance between the rest position is the middle position. Here's the middle position to the top. So I'm looking at the vertical distance between the middle, okay, the middle, which is here, to the top is my radius, and so that's that length there. Okay, and that's it. Ferris wheel questions. You can try the other two questions if you'd like. We'll do them in class. That's it for this sort of stuff. Test, know your Ferris wheels. That's it. Know everything, but especially Ferris wheels. Take care. It's been a great 2015, guys. See you later.